Hello friends, you are most welcomed in Rankari video channel. Friends, I am working about NEET program, up to year program, and in this unit I will describe about application of dimensional analysis. Application of dimensional analysis, the method of studying a physical phenomena on the basis of dimension. The method of studying a physical phenomena on the basis of dimension is called physical analysis. Following are the three main uses of dimensional analysis. Application of dimensional analysis. My heading is my today's topic is application of dimensional analysis. Application of dimensional analysis. The method of studying the method of studying a physical phenomena a physical phenomena on the basis of dimension is called physical analysis. Following are the three main uses of methods of usage of applications of physical analysis are as follows. First is to convert a physical quantity to convert a physical quantity from one system of units to another. From one systems of unit to another. Second is to check the conversion of a given physical relation and third point is to derive a relationship between different physical quantities. To derive a relationship between different physical quantities. My first heading is conversion of one system of physical unit physical unit to another physical unit. How can a physical quantity be converted from one system of unit to another? Explain it with the help of a suitable example. To convert a physical quantity from one system of units to another, it is based on the fact that the magnitude of a physical quantity, the magnitude of a physical quantity remains the same. Whatever may be the system of unit. Whatever may be the system of units. If U1 and U2 are unit of measurement, if U1 and U2 are the units of physical measurement and N1 and N2 are N1 and N2 are the corresponding numerical values. Corresponding numerical values. Then the physical quantity Q will be Q equal to N1 U1 equal to N2 U2. Second point, checking the dimensional consistency of equation. Checking the dimensional consistency of equations. State the principle of homogeneity of dimension and what is its basis. Our heading is Principle of Homogeneity of Dimension. Principle of homogeneity of equations. According to this principle, a physical quantity will be according to this equation, a physical quantity will be dimensionally correct. Will be dimensionally correct if the dimension of the all terms, if the dimensions of all terms occurring on both sides, occurring on both sides of the equation are same. Both sides of equations are same. This principle is based on the fact that this principle is based on the fact only the physical quantity of the same kind, only the physical quantity of the same kind can be added, subtracted, or compared, Thus velocity can be added to velocity. Thus velocity can be added to velocity, but not to added with force. Our problem is how can we check the dimensional correctness of physical equation? Explain with a suitable example. To check the dimensional correctness of physical equation, for this purpose we make use of principle of homogeneity of dimension. If the dimension of all the terms on the both sides of equation are same, if the dimension of all the terms of both sides of equation are same on the basis of homogeneity, then the equation is dimensionally correct. Then the equation will be dimensionally correct. Example. Let us check the dimensional accuracy of. Let us check the dimensional accuracy of S equal to ut plus half at square. Ut plus half at square. Dimension of different terms are S equal L on the right side and the dimension of right side equal to u into t plus half at square, or u upon t, u equal L upon t into t plus half, और a का डायमेंशन LT minus 2 into 2 square, it becomes L plus half L, dimension becomes L. The dimension of physical quantity S is L on the left side, and the dimensional quantity of ut plus half at square equal to L on the right side. Then the dimension of both sides of equation are same as L, then the physical quantity is correct. Physical quantity is correct, and this is the principle of homogeneity. Now we will discuss about significant figures. Significant figures. What is meant by significant figures in a measured quantity? Significant figures are normally those digits in a measured quantity which are known reliably, or about which are have confidence in our measurement of plus one additional digit that is uncertain. The significant figures are normally those digits in a measured quantity which are known reliably, are about which we have confidence in our measurement plus one additional digit one additional digits that is uncertain. That is uncertain. The larger the number of significant figures, the larger the number of significant figures in a measurement, the higher is the accuracy of the measurement. The higher is the accuracy of the measurement. Suppose the time period of a simple pendulum is 1.62 seconds. Suppose the time period of a pendulum is 1.62 seconds. This digit 1 and 6 are reliable and certain. This digits 1 and 6 are reliable, while the digit 2 is uncertain. While the digit 2 is uncertain. So the time period has 3 significant figures. So the time period has 3 significant figures. So the significance of figures of physical quantity is the number of figure by which any physical quantity can be represented by very accuracy and correctness. किसी भी संख्या को जिन उचित अंकों के द्वारा हम व्यक्त कर सकते हैं वो संख्या हमारी क्या कहलाती है? सार्थक अंक कहलाती है. Now we will discuss about rules for determining the number of significant figures. Rules for determining the number of significant figures. All non-zero digits are significant figures. Second point, all zero between two non-zero digits, all zeros between two non-zero digits are significant figures. Third point is all 0 to the right of a non-zero digit, all zeros, to the right of a non-zero digits are significant figures. Next point, but to left of an understood decimal point, but to left of decimal points are non-significant figures. The number of significant figures does not depend upon the number of significant figures does not depend upon on the system of units, on the system of units. Our next problem is state the rules for rounding of a measurement. Rules for rounding of a measurement. Rules for rounding of a measurement. If the digit to be dropped is smaller than 5, if the digit to be dropped is smaller than 5, then the preceding digit is left unchanged. If the digit to be dropped is greater than 5, then the preceding digit is increased by 1. If the digits to be dropped is 5 followed by non-zero digits, then the preceding digit is increased by 1. If the digit to be dropped is 5, then the preceding digit is left unchanged. If it is even, and if the digit to be dropped is 5, then the preceding digit is increased by 1 if it is odd. If the digit to be dropped, if the digits to be dropped is smaller than 5, is smaller than 5, then the preceding digit is left unchanged. Then the preceding digits is left unchanged. If the digit to be dropped is, if the digits to be dropped is greater than 5, then the preceding digit is, then the preceding digits is increased by 1, if the digit to be dropped is 5. Third point, if the digits to be dropped is 5 followed by non-zero digits, then the preceding digit is increased by 1, then the preceding digits is increased by 1. Fourth point, if the digit to be dropped is 5, if the digits to be dropped is 5, then the preceding digit is left unchanged, then the preceding digits is left unchanged if it is even. Next point is, if the digits to be dropped is 5, if the digits to be dropped is 5, then the preceding digit is, then the preceding digits is increased by 1 if it is odd. If it's odd. Our next problem is arithmetic operation with significant figures. Arithmetic operations with the significant figures. The result of an arithmetic operation involving measured values of quantities cannot be more accurate than the measured values themselves. So certain rules have to be followed while doing arithmetic operation with significant figure so as to ensure that the precision of the final result is consistent with the precision of the original measured values. Significant figure in the sum or difference of the two numbers. Significant figures in the sum or difference of two numbers In addition or subtraction, the final results should be reported to the same number of decimal places as that of the original number with minimum number of decimal places. In addition or subtraction, the final results should be reported. The final result should be reported to the same number of decimal places. To the same number of decimal places as that of the original number with minimum number of decimal places. With minimum number of decimal places. Second point, significant figure in the significant figures in the product or quotient of two number. In multiplication or division, the final result should be reported. The result should be reported. To the same number of second figure. To the same number of significant figures as that of original number. Numbers with minimum number of significant figure. With minimum number of significant figures. Now we will define accuracy and precision. So friends, I will describe you in our next video link about accuracy and measurement. So you are requested to wait for my next video links, and if my content is on the basis of your requirement, then you are requested to surely like, subscribe and share my video link. My video link is Dr. Y.P. Singh, Nirankari. Thanks.